Voyager 2 is still sending measurements from a region beyond every other human-made object. The probe crossed into interstellar space years ago, already deeper than anything else we have ever launched, and it is still transmitting data from a place where the sun no longer controls the pressure, the density, or the magnetic field. But the mission is no longer defined by how far it goes. It is defined by how long it can still talk. That one constraint already tells you the endgame is more complicated than distance alone. By the end of this case file, you will understand exactly what that clue means and why the surface gives you no warning before the signal fades permanently. We view Voyager 2 as a distance story, but through a forensic lens, Voyager 2 is not a distance story. It is a power story, and the consequences spread from there. The probe loses about 4 watts of electricity every year as the plutonium inside its radioisotope generators decays. 4 watts is roughly enough to power a single light-emitting diode bulb. That loss sounds trivial until you map it onto a spacecraft that was never designed to operate this long, in conditions this cold, with systems this old. Engineers are now switching off instruments one by one to keep the transmitter alive. The plasma science instrument was turned off recently, not because it failed, because keeping it on would have drained the battery below the threshold needed to encode and send data packets back to Earth. That is not a repair decision. That is triage. And triage only happens when the system is running out of time. Look at it. The spacecraft is not slowing down. It is not braking. It is not drifting off course. It is simply losing the ability to tell us what it sees. The final, scientifically meaningful stretch of the mission is happening right now, in the narrow years between full instrument operation and total electrical silence. After the transmitter dies, Voyager 2 will keep moving. It will pass within 1.7 light-years of the star Ross 248 in about 40,000 years. It will orbit the center of the Milky Way galaxy once every 225 million years. It will carry the golden record for over 1 billion years, long after the Earth itself is gone. But none of that matters scientifically. The billions of silent years that follow are just orbital mechanics. The years that matter are the ones where the probe can still describe what it sees. And those years are running out. NASA estimates that by the mid-2030s, the spacecraft will no longer have enough power to send a signal that even Earth's most sensitive antennas can detect. That threshold is not speculative. It is mechanical. The plutonium-238 inside the generators has a half-life of 88 years, and the decay curve is fixed. You cannot negotiate with isotope physics. The mission is entering the final reachable zone, while communication still exists, and the pressure to extract every remaining measurement is what makes this stretch more important than the launch, the flybys, or the crossing into interstellar space itself. To understand the stakes of the Voyager 2 endgame, we have to look at what the probe is actually measuring right now. Interstellar space is not empty. It is denser than the space inside the sun's bubble. That discovery came directly from Voyager 2's plasma sensors, which detected a sharp jump in particle density the moment the spacecraft crossed the boundary. The heliosphere, the magnetic bubble blown outward by the solar wind, acts as a shield. It blocks about 70% of the galactic cosmic rays that would otherwise hit Earth. Outside that bubble, the radiation environment is harsher, the pressure is higher, and the magnetic field no longer points back toward the Sun. Voyager 2 is the only human-made object currently measuring that environment from the inside. The probe is mapping the interstellar magnetic field, tracking how the Sun's influence fades, and detecting how the boundary itself moves as the solar cycle breathes in and out over its 11-year rhythm. Even in interstellar space, the spacecraft can still feel the Sun breathing. The heliosphere expands and contracts, and Voyager 2 is positioned at the exact point where the outward pressure of the solar wind finally loses the tug-of-war against the crushing pressure of deep space. That measurement is not theoretical. It is direct. No telescope can see it. No model can simulate it perfectly. The only way to know what interstellar space looks like is to go there and measure it. And Voyager 2 is the only probe that has done that from a southern trajectory. The loss is not just that the probe will stop transmitting. The loss is that there is no successor mission. Voyager 2's path is a one-time only physical cut through the transition zone between our Sun and the stars. And once the signal dies, that cut is over. But the deeper problem is the communication architecture itself. Only one antenna on Earth is powerful enough to send commands to Voyager 2. That antenna is the Deep Space Station 43 in Canberra, Australia. The reason is geometric. Voyager 2 flew south after its encounter with Neptune in 1989, and its trajectory took it below the plane of the solar system. Northern Hemisphere antennas cannot see it anymore. The spacecraft is visible only from the southern sky, and DSS-43 is the only dish in NASA's Deep Space Network with both the southern view and the power to transmit commands at the frequency Voyager 2 can still hear. If that antenna goes offline for maintenance, or if its transmitter fails, the probe becomes unreachable. Commands sent from Earth travel at the speed of light and take about 22 hours to reach the spacecraft. The reply takes another 22 hours to come back. That 44-hour round trip makes real-time troubleshooting impossible. If something breaks, engineers cannot react quickly. They have to predict the failure, write the fix, upload it, and wait nearly 2 days to see if it worked. And because the spacecraft is running on 48-year-old hardware, with less total memory than a modern car key fob, every command has to be written in software so old that engineers often consult paper manuals from the 1970s just to understand how the flight code behaves. The system is fragile not because it was built poorly. It is fragile because it was never designed to last this long. The fuel lines have to be heated constantly to keep the hydrazine from freezing solid in the minus 450-degree cold of deep space. The heaters drain power. The tape recorder that stores science data before transmission is an analog relic that has been spinning for nearly 5 decades. The high-gain antenna has to stay pointed at Earth, within a fraction of a degree, or the narrow signal beam will miss the planet entirely and be lost forever. If the onboard computer loses voltage below a critical threshold, it will no longer be able to encode science packets, even if the instruments themselves are still working. The transmitter will still be on. The sensors will still be collecting data, but the spacecraft will have no way to tell us what it sees. That is the failure mode NASA is trying to delay. not mechanical death, communication death. This creates a reinforcing failure loop. Every watt saved by turning off an instrument buys a few more months of transmission time. But every instrument turned off reduces the scientific return of the mission. The plasma science instrument is already gone. The ultraviolet spectrometer might be next. Eventually, only the magnetometer and the cosmic ray detector will remain, and even those will drain the battery faster than the decaying plutonium can recharge it. The mission is not ending because the spacecraft is broken. It is ending because the power curve and the communication threshold are converging, and there is no way to stop that convergence. The system also shows that distance is no longer the limiting factor. Voyager 2 is currently about 20 billion kilometers from Earth. That sounds impossibly far, but it is still nowhere near the true edge of the solar system. The Oort cloud, the vast shell of icy bodies that marks the Sun's gravitational boundary, begins roughly 1 light-year out. Voyager 2 is currently about 0.002 light-years from the Sun. It will not reach the inner edge of the Oort cloud for another 300 years. By then, the transmitter will have been dead for centuries. The golden record will still be intact. The spacecraft will still be coasting on the momentum it gained from gravity assists in the 1980s. But it will be completely silent, drifting through a region of space that no human will ever see described in real time. The final data packet is expected to be a simple carrier tone, a heartbeat signal that confirms the transmitter is still on, but no longer strong enough to encode science. After that, the tone will fade below the noise floor of Earth's antennas. And the mission will be over. Not because Voyager 2 stopped, because we stopped being able to hear it. And the harder part is that this is not a sudden failure. It is a slow dimming. By the time Voyager 2's signal reaches Earth, it is already billions of times weaker than the power of a digital watch battery. NASA's Deep Space Network antennas are sensitive enough to detect that whisper, but only barely. As the spacecraft's transmitter loses power, the signal will fade gradually, dropping closer and closer to the background radiation of the universe itself. There will be no dramatic cutoff, just a slow descent into static, and then silence. You, the viewer, should watch the instrument shutdown schedule next. Every time NASA announces another sensor has been turned off, that is not a maintenance update. That is a countdown. The mission is now measured not in distance traveled, but in instruments still alive. The magnetometer is still running. The cosmic ray detector is still running. The transmitter is still strong enough to be heard. But the voltage is dropping, the power curve is steepening, and the margin for error is shrinking every year. What looks like normal mission operations is really the most advanced form of the endgame. The spacecraft is operating exactly as designed, sending data exactly as planned, and still running out of time. So here is the answer to the question from the beginning. This is what that clue means. The final zone Voyager 2 can reach, while it can still talk to us, is not defined by how far it can go. It is defined by how long the transmitter can stay above the threshold where Earth can still hear it. That threshold is a function of decaying plutonium, instrument shutdowns, and the fixed sensitivity of our antennas. The zone is not a place, it is a time window, and that window is closing. That is not a projection. That is the system behaving exactly as the evidence suggests. Voyager 2 is not broken yet, but that is the point. The mission will not end with a failure. It will end with a fade. Most people see the distance. Now you can see the mechanism.